Good afternoon, good evening, good morning from wherever you are joining us around the world. My name is Michael Watson and welcome to a Microsoft Reactor live stream event. As I said, my name is Michael Watson. I have the pleasure of leading the Microsoft Reactor program in the Asia Pacific. And today I will be joined by Daniel Scott Rainsford, best known at Microsoft as DSR. And he'll be taking you through a fantastic session about supercharging your apps with GPT and Azure OpenAI Service. I won't run through DSR's bio right now, but you have the opportunity to go and check that out on the registration page, so I do encourage you to do so. Before we kick off the session, I want to draw your attention to our Reactor Code of Conduct. In short, this is basically just telling you to make sure that you behave appropriately, constructive with your comments, and respect all those that are joining us on the event today. DSR will run you through the agenda of the event shortly. However, please make sure you do send your questions and comments in the chat, and again, respect the code of conduct when doing so. Additional links will be shared during the session. They are in the chat. Links to things like our survey, which we would encourage you to complete at the end of the session to help us learn what more content you'd like to see going forward. Without further ado, I will now bring Daniel into the stream and he will take over. So welcome DSR, welcome to the stream, and I am going to hand it all over to you to take everyone through your amazing session.
Thank you, Michael. Thank you, everyone. Welcome, kia ora from New Zealand. I'm really pleased to be here. I'm pleased that you've chosen to share your time with us. This is probably one of the most exciting technologies and evolutions in technologies we've seen in a long time. We're hearing it compared to the evolution of the smartphone or the desktop PC. So we're going to crack into this and we've got a lot to cover. I want to first start out with basically grounding us in what is generative AI, what does it actually mean, and what are we going to see done with it. We're then going to look into the Azure OpenAI service and how you can get access to it and what it is able to do for you. Then we're going to play around in the playground, which is your space for building your proof of concepts and really get stuck into this technology. I'm then going to pause in the middle for a bit of Q&A. My experience with this technology, there's so many questions that come up as we go through it, and I'd like to get a little bit of a head start on those and answer some of your questions before we move on to some of the more deeper detail around use cases, models, and the APIs you'll be using to add this technology into your applications. Then we're going to take a look at the exciting concepts around prompt engineering. Now, you may have heard about this. We're going to look at some of that in detail, and then we're going to talk about orchestrators. Finally, we're going to talk about the biggest question I get asked, which is how do I build ChatGPT and use it over my data? And then show you some next steps and follow up with a little bit more Q&A because I'm sure there will be some more questions. So let's get started. I am sure no one here would be surprised or hasn't been bombarded with large language model, GPT, OpenAI, questions or headlines in the news. It has been nonstop. I don't know about you, but it is overwhelming. So I'm going to try and cut through some of that. I thought, as this is a Microsoft session, we'd usually start with a bit of a quote, a bit of an inspirational quote. I have dug through all of the amazing leaders in technology, and every one of them has an amazing quote about this, but this is one that jumped out at me. I had to generate it myself because there was just too many to choose from. So this is an example of using GPT-4 and DALL-E to create new content just by asking a few bullet points and providing a few bullet points to this technology. It created me quite a convincing and inspirational quote. This was generated via Bing AI. I'm sure, as some of you have been aware, Bing has had a bit of an overhaul lately with the GPT-4 and DALL-E models being provided behind them. And this is really starting to show the ubiquity of this technology being added into so many of our tools that we use day to day. But let's start off a little bit with talking about AI. We're all familiar with AI. We've it's been around for many, many years, or the concepts have. It's such a broad term, and we use it in so many different ways. We are seeing a boom in a specific area of artificial intelligence called large language models, and they are often referred to as generative AI. These are programs for natural language processing, and they use deep learning and neural networks. There are lots of different versions of these large language models, and they're produced by various companies. Microsoft is working closely with one of these companies, which is, of course, the company OpenAI. And they have produced some amazing technology, some amazing models, large language models. This includes the GPT models, which you're familiar with for text generation, and the ChatGPT model, which is actually a form of the original GPT models, and then the DALL-E and Codex models as well. But we will jump into them in much more detail. So what do these generative models do for us? What can they do? And all of us are familiar with chat, right? We've probably used ChatGPT, or we've used Bing AI, and we've used this technology. But where we're seeing the technology used in other areas is around things like translation and creation of new content, and email generation, image creation, extraction of data, understanding and reasoning over data, classification, summarization. All of these techniques can be leveraged and used by these engines. So with just a few lines of input, we can basically create so much new content, or generate or control these models to help us solve so many problems. But the key here, these are pre-trained foundational models. So what is a foundational model? A foundational model is a model that is not designed to solve one specific task. Many of us are familiar with AI, such as computer vision, or speech-to-text models, or form recognizer. These are all models that are trained to do a very specific task, and they're classified as narrow models. Foundational models are more general. They are not specifically trained for a single task. Now, these foundational models are trained on a very large corpus of data, and they are trained from a point in time. And many of you will be familiar with that. These models often stop at 2021, because that was when then the corpus of data was obtained. They're not connected to the internet, and this is an important distinction we'll talk about a bit more later. We're often used to using these models in a very interactive way. We've got a chat interface hooked up, and we're able to interact with these models, typing prompts and getting responses and follow-up questions. However, we're seeing many use cases that are non-interactive, that are processes behind the scenes, automating tasks, providing us with value without us having to interact directly with them. And these models, these capabilities, come with a completely new approach to engineering. Many of us, myself included, are engineers, and we're used to the syntactic model of writing code. Whereas these models allow us to semantically communicate with them to control what they do. And this has given rise to prompt engineering, which is how we get these models to do what we need them to do in a predictable way. So let's get on to the next. So the biggest question I'm sure many of you've got to ask is, how can I add generative AI to my application and leverage the security and the compliance within Azure? This has led to, obviously, the partnership between Microsoft and the OpenAI company to bring the models, the OpenAI developed models, into the Microsoft ecosystem under Azure. As part of that, all of the following 5 classifications or types of models have been made available inside the Azure OpenAI service. And I'm going to go run through these 5 different classifications of models. GPT-3 is probably the first model that was developed. It is a text in and text out model. You send text to the model, it will respond with text. The second model that I'm sure many of you are familiar with, but you don't necessarily realize it, is the Codex model. This is a code in, text out, or text out, code in model, and it is used by GitHub Copilot. So if you're familiar with GitHub Copilot and you've used it, chances are you've used the Codex model. DALL-E is text in, image out. That is available, but it's in preview. The ChatGPT model, which is actually a form of GPT-3, or a fine-tuned version of GPT-3, that is what we call a conversational model, or a text in, conversation out model. And finally, the newest is the GPT-4 series of models. Now, these are actually multimodal. They are also in preview. Multimodal means they are text and image in and text out. So you can actually provide them with images as well as text and ask the models to reason over those. So all of those 5 models have been made available inside a new service in Azure called the Azure OpenAI Service. Now, if you've used Azure for a little while, if you use some of the other AI products in Azure, you'll be maybe familiar with computer vision and speech, which generates text to speech and speech to text. You might be familiar with some of the other services, but OpenAI is in that customizable AI models, meaning that these models are already trained for your use, but they can be customized in certain ways. But we'll go into a little bit of that later. So what makes the Azure OpenAI service a little bit different, or a little bit different to what you may have used if you've used OpenAI? So the first thing is these models are deployed into your Azure subscription, and they're tied to your data sets and your applications. So you get to secure it, you get to define how your applications or your users will communicate with that. They are the same large pre-trained AI models that OpenAI provides, but you're also able to customize or fine-tune these models. Now, this is important. This doesn't add knowledge to your models. You can't take an existing model and add in the last 2 years of internet knowledge, but it does allow you to change how the model behaves and how it performs. The next thing is Microsoft is very, very committed to the responsible AI framework. It is wired into everything we do. Built-in responsible AI is inside the Azure OpenAI service, and it provides guidelines and gates to make sure that the service is being used in a responsible way and meets those responsible AI guidelines. Enterprise grade security. So this allows you to control the service and access to the service via RBAC, role-based access control. Use Azure AD authentication, which is very important. It's much more secure than key-based, API key-based authentication, and also allows you to put it inside private networks and govern the networking between your application and the Azure OpenAI service. And then finally, if you're familiar with Azure, using many of those Azure monitoring tools, you can integrate Azure OpenAI service with those monitoring tools and get that observability over your entire environment. So we're going to jump into some demos in just a moment, but I thought it was really important because this is such an important thing to Microsoft, and this is such an important thing, I think, for the world, is this trust and responsible AI. Right now, this is a limited access service. You do need to request access, and we will provide the link at the end, and you can go and look at the document outlined below for more visibility on that. But we need to comply with those responsible AI guidelines and framework. So it also, right now, because there is such high demand for this, you do need to be a corporate partner or a customer of Microsoft to get access to this. That will be changed in future as the service progresses, but just be aware you will need to make that request. Another point is your data is your data. This data is not used to train the models. Anything you send to these models does not get used to retrain the model. It's not used for any other purpose except for checking the filters are doing the right thing and filtering the data in the right way, but the data is not used or accessed by Microsoft. Your data from any fine tuning is not used to train the foundational models. So if you choose to fine tune them, which most users will not need to do, that data will still not be used for those models, fine tuning other foundational models. And your data is protected by the most comprehensive enterprise compliance and security controls. So all that networking stuff. So just wanted to get that clear, because those are some of the questions we get asked, and I want to just make really clear up front that this is such an important thing with this very powerful technology. So I'm going to jump straight into our demos. So Azure OpenAI Service. It is a service deployed into your Azure environment. So you're going to need to start by deploying yourself an Azure AI service. This is deployed like any other service in Azure. I can just OpenAI, and I can go and create a new OpenAI service, select a resource group, and select a region. Now, there are currently 3 regions available. If your use case requires a region that is different or requires certain governance, for example, data residency requirements that do not permit you to use one of these regions, then you won't be able to use the service right now. So you have to select one of these regions, select a name. Pricing tier is the same, so I'll just go DSR Demo Europe and select my networking options, and we're done. That's pretty much it. The rest is very trivial. Once we've done that, we will have a shiny new Azure OpenAI service deployed into our subscription that we can then put access control over. We can define who has access to it, etc. But the first thing we're normally going to have to do is choose models to deploy. Now, this is slightly different in when you use other services. The models may already be deployed for you. But the good thing about Azure OpenAI is you can choose which models you would like to make available in your service. You can deploy one of each type of model, and there are lots of models, and we're going to go through those shortly. But I've actually deployed these models. I would normally just say, look, I want to deploy Text DaVinci 02 and give it a name, Text 02, and voila, and it will deploy that model. But the models basically provide the features and the everything you're going to be doing with that service. I will jump straight over back and show you the more interesting stuff in the overview. When you deploy the service, you are going to receive an HTTP endpoint. This is where your applications will connect to. Now, depending on which models you've deployed and the names you've deployed, you will have additional paths on that endpoint, which you'll then be able to use to connect to the various different models. For example, if you're using chat, you might use the GPT-3 Turbo model, and that will provide you with a specific endpoint for that. But first thing we are typically want to do is we're going to go straight into the Azure OpenAI Studio, which is here, or we can click Explore and it'll take us there. When we land in the Azure OpenAI Studio, we're going to be presented with this. This is going to be our place for experimentation and testing. We're going to spend a lot of time in here. We'll be prompt engineering in this space. And it provides us with a bunch of tools for getting started. It gives us some simple examples here. We can basically say, oh, if I wanted to summarize an article, this is the sort of prompt I would use. I would ask the model to do this, and this is the response I might get. It'll also show me the Python code that I would use to automate this process or add this process to my application. So I'm going to close that, and I'm going to head over to the completions playground. Now, there is 2 playgrounds, one for text in, text out models, and the other is for conversational models, and that is the chat models. We're going to start by jumping over to the completions playground with some chat models. Now, I'm going to show you an example of this is a conversation between a claims agent, someone who's just had a car accident. This is a transcription. There is no indication of who's saying what. It is just a pure blob of text. And we're asking the model, in this case, we're asking the Text DaVinci 003 model, and we'll talk about the models soon. We're asking it to extract information from this. We've asked for 6 different pieces of information, and we're just going to select generate. Now, don't worry too much about the parameters. We will cover that shortly. And it's going to take a few seconds, and we're sending this to the the Text DaVinci model, which is a very, very powerful model, but it's part of the GPT 3.5 series of models. As you can see, it has extracted that information. If we ran this query again, we're actually going to get slightly different information. We'll get the same meaning, but the wording might be different. And this is because these models are not deterministic. We have something called a temperature, which allows us to change the level of determinism of the model. If we have a very high temperature, the model is likely to be more creative with the response, which is going to give us a slightly different result. So if we want a very deterministic result, we will typically turn down the probabilities and the temperature. And that will give us this, typically give us almost the same result every time. But this is great, but I can imagine if any of your engineers out there, you're going, this is going to be kind of hard to use in my application. Can't you give this to me in a better format? Well, why don't I ask the model to do that? So I'm going to change things up a little bit, and I'm going to ask the model to do this. Oh, this is the exact same conversation. Here's my phone conversation. But I have again used the same same information, use the extract the information, but I've also said I want these fields to be answered in short. I want them to be JSON, machine readable format. And I want you to use the keys from the above, as you can see here. I've put keys in, and I've asked in this case an array of driver names. And I've also said, make sure you print the JSON, otherwise we just get a flat JSON string, and make sure it's closed at the end. So let's see how that goes. So as you can see, it's created a results object. It is provided the array of names. And as you can see, now I could just take that result, chuck that into a JSON to object serializer, and boom, we've got an object a POCO we can now work with and deal with. This is the sort of this is how fast our development time or build time, or the way we can start to work with these models, can really change how fast we can get things to market and POC things. Let's try another one. Let's have a look at this is an example. I like to run a virtual tabletop in a container in Azure. This is the container logs from my virtual tabletop. I'm going to dump these into the model, and I'm going to say, look, summarize the container logs and identify any issues for me. Now, there are some issues in here, and I made sure there were. Obviously, I don't want to have to read all this text, but let's see what the model comes up with. So I'm going to dump all that in there. And as you can see, the logs indicated that it was initialized, but it took 10 minutes to start. And also the software license verification failed, and it also told me the server is listening on port 3000. And it correctly indicated this could indicate an issue with the license key or a problem with server configuration. So I didn't have to ask it or tell it what to look for. It figured it out. And that is the power of these sorts of models. Now I could, of course, say, extract this as JSON, and it will go and give me that list in JSON. And I could then go and process that in other ways. So let's take another look at another example here. What have we got? We're going to, this is an example of clinical documentation creation. So far we've been looking at extraction. This is creation of a new clinical document. This is a referral letter for a patient at a hospital. We have got some clinical information about the patient's recent visit, and this is all stuff that either the doctor wrote or could have been automatically extracted as part of the medical system. And I'm just going to click create. And as you can see, it's created the content, it's added relevant information from relevant clinical information, and it's gone and sent that into ready for the doctor to send. Now, what to say is the doctor's preferred language is French. So let's see what happens. I'm just going to delete that response, and I'm clicking how that goes. So now we have got an answer or a letter in French. So this leads us to be able to do things like hyper-personalization, localization for both our applications and our users. So why can't a user or a doctor specify the language they wish to use? Why can't any of our users expect to receive documentation or information in the language they choose? So we're able to start to open up how we are using our application and the experience for our users. So this is really quite game changing. Now, what I'm going to do is I'm going to show one last demo before I move on to the next thing, or a couple of last demos actually. So what I'm going to do is I'm going to show another technique, which is natural language to SQL. Actually, I'm going to do natural language to SQL. So in this case, when I choose the natural language to SQL example, it's asking me, hey, look, we recommend a different model for this. So if anytime you're working with code to text, or text to code, or reasoning over code, you're going to want to use a slightly different model. Now, the models you want to use are the Codex models. And this is the Code DaVinci 002 or Code Cushman 002. Recommend DaVinci because it is the better of the models and more powerful of the models. So I've now deployed that model. It took me only a couple of seconds and it's there. So I now switch to that model. And what it's doing is I have some comments here and I'm saying these are the tables, and I want you to tell me give me a query that lists the names of these departments which employed the 10 employees in the last 3 months. Click generate, and I'll refresh my window because obviously the deployment hasn't. Well, that goes. I'll jump into this one, do the same thing. Not explain a query, natural language. So we'll run it in this one. So now this is going and sending this request. Now, it has generated a query that satisfies my requirements. Now, you can imagine if you had a reporting system, or you were building a reporting system for someone, you knew the structure of all the tables, you could quickly and easily add a natural language query engine over top of your application. Obviously, you would want to put guardrails in here, and you wouldn't want to just allow the customer to query anything, but you can see the power of this technology and how easy it is to implement. So one last example, I'm going to chuck in this generate insights. I love this one here. We need to use the DaVinci model here. This is really extracting insights and meaning out of some very, very complicated and very difficult to understand information. So this is showing different products and their performance, and we want to get some meaning out of this. So we're going to click generate. And again, it's not liking me switching the models, so I will go back here and I'll do it in this one here. Here we go. So that's a little bit strange. I will, okay, I had a stop sequence in there which told it to stop sending as soon as it hit a carriage return, which is not not exactly what we want to do. So that is why that was failing there. So we'll click generate again, and we won't use the stop sequence, and it will produce the insights that we need. Now we could ask this to put this as bullet points. We could then output that as JSON and use that in other ways. So as you can see, this is the sort of things these models can help us achieve. So that's all. We're going to move back and we're going to start to go into some more complicated demonstrations, and we're going to talk about a few of the other concepts around prompt engineering. Before we do that, I just want to pause and see if there are any questions or anything in the chat. And I saw there was a question there. Is there a limit on the amount of data that we can feed in? Traditionally speaking, with overlogging, rubbish in, rubbish out. Now, there is. Now, that is an excellent point, William. So we have this concept of tokens. Every request and every model has a limit to the number of tokens you can send in. And a token typically represents about 0.75 of a word. If we want to actually model will see what tokens look like. We've got a handy little tool here from the team at OpenAI, and that will actually show us how the tokens are broken, how text is broken down. But these models, when we pass the information into them, we are limited by the number of tokens that that model can accept, and we can also define how many tokens the model will return. Now, for example, the Da Vinci model, the most capable of the GPT 3.5 models, can accept 4,000 tokens. So that means we can send in a maximum of either 3,000 tokens in and 1,000 tokens out, or some combination up to 4,000 tokens. Now, what you're referring to is if we allow the model to output as many tokens as it can, it may output more the information than we actually need, and it tends to rabbit on. It will waffle on. So we often need to define how many tokens or limit how many tokens based on what we think we're going to need. We also need to probably, what we typically think of is when we start to write our prompts, we think maybe we'll need 100 tokens. But if we're able to be more specific, we may end up with longer prompts, which will result in more tokens, and especially if we need to provide additional grounding information. So how can we utilize the models in the downstream application? Amazing question, because that is exactly the next next part of the session. So I'm going to get onto that in just a moment. But if functionally, before we get there, functionally, we are talking about REST APIs. These are these models are surfaced as REST APIs, and we will we'll show you how to use those. But I think in the interest of time, we'll jump forward, and then we will do more questions at the end. I'm sure you will have more. And feel free to reach out to me on LinkedIn. If I don't get to your questions and you have anything you really want to ask, please ping me on LinkedIn. I will endeavor to answer your questions as quickly as possible. So jumping back into our Q&A. So which models should I use and how can I use them in my application? Hopefully that is lining up with everyone's requirements now. So as I said, there are multiple models available. You can choose the models you want to use, and you kind of need to look at your use case and decide on the type of model, so GPT-3 or DALL-E or ChatGPT, and also the level of features or capability of the model. And I'll show you that in just a second. But if your use cases typically land in these areas around, semantic search, summarization, and content generation, you're going to be looking at GPT-3 or 4 or DALL-E. That's not to say you can't do a lot of this stuff in the ChatGPT model, because you can. If you are looking for really building a chat-based service, you're going to use ChatGPT or GPT-4. Now, the GPT-4 models are actually designed to be used as chat, and they're very much tuned in that method, but they can also be used in the more content generation, summarization, extraction, etc. And then finally, anytime you want to work with code, text to code, code to text, code documentation, unit test generation, all those sorts of things, that is going to be your codex models. So how do you go about integrating or adding this into your application? I've got some demos, so I will jump into that. So if you are using you're using C#, right now your best bet is going to be the .NET Azure.ai.openai NuGet package. So that would be .NET or VB or C#. There are more coming. If you are using OpenAI or even Azure OpenAI, you can use the third-party SDKs and packages. So OpenAI provides a Python package. There are many more. There is a lot of organizations have created many more third-party packages, and you can choose to use them. The thing I'd call out there is Azure OpenAI supports Azure AD authentication. So whichever package you are using, typically when you productionize in a corporate or enterprise environment, you want to consider, can you use that Azure AD authentication? And you want to make sure those packages support that. Many of them do, some of them don't. Just have a look at that. But for me, I've typically used the .NET ones, but as I said, whatever your choice is, there are going to be those packages available. The paved path. Now, You may have been heard about or familiar with LangChain. You may have come across these tools that are being built with LangChain. LangChain is amazing, and this is what we call an orchestrator. It's an abstraction or a framework that sits above these large language models and provides more services that these language models need, and give us a way of connecting those models with a bunch of different data like memories and connectors and so on. LangChain has been around quite a while. It's built in Python. Semantic kernel is one from Microsoft. It's another open source. We will be going and demonstrating that. It is designed to use Azure OpenAI plus a number of other services, and also connect with a number of other technologies that Microsoft provides, plus third-party technologies. And of course, the fallback position is you can just call these with REST APIs, right? You can just fire a REST API call at the APIs and you'll be good to go. So, as I said, there are each of these models, there are different levels. So in the GPT-3, there are 4 models. There is the Ada, Babbage, Curie, and DaVinci. The DaVinci model is the most capable, but it also has the largest number of tokens, but it also has the largest inferencing time, which means it's actually costs the most. But its capability is extremely powerful. It can do almost anything you throw at it. However, on the other end of the spectrum is the Ada model, which is very simple. It can do very simple things, but it is very, very fast for inferencing. And it supports less tokens. It is great for classification. What you will need to do is decide on which of these 4 models or levels of model you need for your particular use case. And you may find that DaVinci is beyond what you need. So there is often a little bit of trying these different models. The second class of models that we need to decide from is the codex models. If you are using those, the DaVinci codex is the most powerful, but it requires larger inferencing time. So it is important to consider which one of those 2 models is going to be the best benefit for you. So I'm going to rush through the APIs. It's just worth knowing that they exist. There are essentially 3 APIs you're typically going to work with. For the GPT models, there is the completion API and the embeddings API. I'm not going to go too much into detail on embeddings, but the completion API is the API which you will send text in and you will get text out. It is pretty simple. It can't be used for GPT-4 models, though. It can be used for the ChatGPT model. But you need to pass in a very special format of prompt, and we will talk a bit about that. The ChatGPT and GPT-4 models, however, you've got a choice of 2 APIs that you will use, and most SDKs, most packages that are going to expose these will expose both the chat completion API and the completion API. So the chat completion API is used for interacting with GPT-4 and ChatGPT, or the GPT-3.5 turbo model. So you will need to communicate with those using a specially formatted JSON string, which I'll show in a second. And then finally, if you want to use the completion API with the ChatGPT model, you can, but you need to use the ChatML format of string when communicating with it. Otherwise, you'll get some weird behavior. The ChatGPT model, interestingly enough, is a fine-tuned version of GPT-3 model, Text DaVinci 002, in case you're interested. So it has been tuned to perform better and to interact using a chat or methodology. So let's just jump back to the playground. As you can see, when I was in the playground, I was really interacting with these models in a very UI-based fashion. If I want to know how would I do this with code, all I need to do is jump to the playground, click View Code, and I get to see the Python code. I get to see the JSON or the payload that was actually sent, including the parameters here on the right. And I can also select C#, which specifies the Azure OpenAI package there. It is using a key credential. Again, I would recommend if you are using Azure OpenAI, use Azure AD, and I've got a demonstration of that shortly. And of course, chuck a curl command. Why not? You could just do this at the command line. So Heading back into our presentation. So this is now moving into what is this prompt engineering I've been hearing about. I think we've all probably heard this term, or you may have heard it in passing and wondered what actually is prompt engineering. Why do we care? Why do we need to worry? What is prompt engineering? So basically, it involves the skillful design of input prompts to improve the performance and accuracy of the model output. I like to think of these models as they are very smart, but they are also a little bit literal. And the more we can communicate effectively with that model, the better the output we will get. So if we're able to explain very clearly to this model what we want, we are going to get better results. Now, prompt engineering is where this is basically the set of these techniques that we're going to use to do this. Now, we could spend an entire day talking about the techniques involved with prompt engineering, but we don't have a day, so I'm going to give you my top 5 prompt engineering tips. But I highly recommend go out and have a look at other prompt engineering tips. Go out and see what other recommendations, especially some of the amazing engineers at OpenAI have got. So, number 1, define a clear goal. What do you want the model to achieve? Be very clear about this is the thing I need you to do. I need you to extract information. I need you to classify and translate. I need you to reason over this data and provide me a clear set of steps. Always start with that. It's very important. Number 2, don't be afraid to be specific, descriptive, and detailed. So it's okay to have 10 bullet points on what you want. Many of us are used to ChatGPT and the chat models where we typically just, how far is the moon? And we just bash out a question. Using these models effectively requires us to define, well, how many units do we want? Do we want it at this time of year? Is it important whether we're standing on a mountain or not? These are all things we need to specify to the model to get the best result possible. And you will have remembered when I was doing the JSON demonstration of JSON extraction, I was very specific about the format of the JSON. I was very clear about what I wanted, and it was okay for me to put a lot of instruction. It is good to put the instructions of what you want at the beginning and then use the context at the end. And we often use, and you'll see hashes or quotes as separators. It's a good idea to add the context, for example, the data we're actually wanting the model to reason over at the end. And then we can often use separators as well as labels for the separators, especially if we've got multiple pieces of data we want to include. We always want to use positive statements. So rather than saying you should not do something or don't output this, you should say, I want you to output this. It's more important to be very clear with the model to what you want it to do rather than what you don't want it to do. An example of this is if you don't know something, don't make it up. That is a very important statement that you would often add to these models because they're designed to be creative. So asking the model to not make up information it doesn't know will prevent hallucinations. And I'm sure many of you have heard the term hallucinations. Remember, these models are designed to create, and we can make sure they don't in certain circumstances by adding those sorts of commands. And then finally, one-shot and few-shot examples. So this is where we include examples of the output we're expecting inside the prompt, as if we are basically fine-tuning the model as we go. Now, this is really important because we will typically think of fine-tuning the model down the track. We will think, well, we need to fine-tune the behavior of this model, when in fact what we can do is just fine-tune it on the prompt level. So every prompt includes fine-tuning or examples that we can use. Now, I'm going to jump back and do some demos of some of these concepts. So I'm going to start first by just showing you Bing AI. I'm sure many of you have seen Bing AI. This is the new GPT-4 built into Bing. But I wanted to say, what is the distance to the moon? Actually, when was Avatar 2 released? Now, this is a really important question, not for the reasons you might imagine. So, Avatar was actually released in 2022. This model, GPT-4, was trained before that date. It was trained in 2021, I believe. So how does this model have that information? This is an example of grounding. We are actually going off and searching, or Bing AI is going off and searching the internet for that information, providing relevant chunks of text and information, and providing that in a prompt back to the GPT-4 model, and as long with our question, and asking the model to reason over it. This is a very important concept of grounding, and we are going to talk a little bit more about that. But typically, if you want the models to have knowledge they don't have access to, you have to ground them by providing that knowledge in the prompt. So I'm going to close that. This is an example of a ChatGPT. We're going to use the ChatGPT model to build ourselves an assistant. Now, you notice before I mentioned the ChatGPT models require certain APIs, either the Chat Completions API or Chat with the ChatML format. We're going to show those. So if I first set the system message. So this is a message that is included in every prompt that tells the model how to behave and what it should do and what it should not do. I will need to set this, and it was submitted with each prompt, each chat request. So I'm going to now say, please recommend me a book to read. Now, I've not provided any useful information to this model. It doesn't know who I am. It knows nothing about me, what I might like. It's going to have a good crack at it, and it's now going to ask me a question. What I might do instead is let's add a bit of grounding information about who am I? Who is, and I might, if I was logged in, if this is on a website, I might be logged in as a user. So I might say, you know what, I'm going to provide a little bit more information. I'm going to provide some guidance to this model. So what I'm going to say, I'm going to tell it, you now suggest books that people might like on their interests. I'm going to provide some additional guidance on how it should act, helpful and funny. It likes to make jokes, and it often mentions The Hitchhiker's Guide to the Galaxy. I'm also telling it, if asked about any other topics of books or any other retailer other than the Nile, you will respond with, I'm sorry, I can only suggest books from the Nile. So again, we are enforcing or telling the model how to behave. Now, if I add, please suggest a book I might like, it might do a better job. It probably won't because it doesn't know my interests. So again, I am going to ground that with some information. So I would provide that in the system prompt because the user would never provide this information, or not usually. And now I've added that I will also not suggest age inappropriate books. And the customer is a 32-year-old named Janet. She's previously liked these and she likes this stuff here. So I'm going to just clear that chat to make a little bit of room. I'm going to say, please suggest a book. Now, so as you can see, it's given me a recommendation. It's looked at all the grounding information I've provided. So this is an example really of how we should start to think about these prompts and how we can start to add this kind of functionality in our applications by providing additional grounding information into the prompts. We could also add examples of how we might want that prompt to be provided. So whenever the user says, suggest me a book, the assistant will say, You bet. Here is one book you might like because you liked another book. So now I've given it a few shot example. I'm going to save the prompt just so that it knows, and I would just say suggest me a book. Now it ignored my you bet, but which I might instead use as just a pure instruction. It's really used that as an example of what sort of information to provide. So if I wanted it to provide a review of the book, I could add that on there as well. I could say here is a helpful review of this. Other book, please. It didn't give me the helpful review, so it's a bit annoying, but we would normally see that sort of example coming in there. So now that we've covered that, I'm going to jump quickly back because we've got a little bit more to cover. So building prompts. As I said, we're now with prompt engineering, we're now spending a lot of time building prompts. We're spending as much time building prompts as we are writing code. So we are now seeing technologies emerge and frameworks emerge that are starting to help us bring together the information we need for these prompts. So bring together grounding information and provide us with additional services that sit around these prompts. So with the flow that you are typically going to see when you're developing your application is you're going to have some form of question or goal that you need the model to achieve. You are then going to bring together skills. You're going to bring in internal knowledge, for example, an index over your internal data stores. You might bring in internet knowledge or searches from the internet. You might be bringing in using connectors from things like Azure AD, your Azure AD graph, your MS graph, I should say. You might be bringing in memories or local stores of recent conversations, and you might be providing examples. All of that information needs to come together in a prompt that we're then going to submit through to the to OpenAI or to the Azure OpenAI service. All of this work is now starting to be taken over by something we call these orchestrators. And as I mentioned, LangChain is an example of that, and semantic kernel from Microsoft. We're going to take a little bit more of a deep dive into the semantic kernel in a moment, but it is important to understand that we're starting to see the orchestrator as the paved path. Rather than just directly interacting with these REST APIs, we're now starting to consider the use of an orchestrator as being a part of our how we develop against these APIs. And finally, we are also seeing techniques such as prompt chaining. This is where the output of one prompt is being used to feed and provide information to another prompt. For example, if we were to ask the AI, the model, one of these orchestrators, write me a book on OpenAI, it would first, the first prompt may give you a set of chapters. You would then feed those chapter titles into the model and ask it to write the content for that chapter. And that is what we call prompt chaining. And that is something these orchestrators also start to enable and make it much simpler. So, as I said, there are other orchestrators, but these are the two I'm most familiar with. These are the two that have certainly made a big splash, especially LangChain. LangChain is very, very popular. It is Python based. Semantic kernel, however, is an open source multi-language platform. It is based around this concept of asking the model to do what you want rather than defining a set of steps. We won't go too much into detail as we just simply don't have the time. But it is a lightweight SDK. It lets you easily mix the conventional programming language with the latest and larger language models and AI prompts, and uses templating and chaining and planning capabilities out of the box. Again, this is actually an early release. There is C# and there is Python version. There are JavaScript and Java versions, I believe, being worked on. They're pretty easy to get going with, but they're early technologies and not everything is there, but it is moving very, very quickly, and they are open source on GitHub, so have a look. I've provided a link at the end. So I'm going to jump back into Visual Studio now, where I have used semantic kernel. So I'm going to go through some code real quick, and then I'm going to show you what the output of that code looks like. So in this case, I have just got a simple console app. I've used the Microsoft semantic kernel package added to my project, and I've used that. I am now creating a kernel using the kernel builder, and this is essentially the core of the service. I'm getting a credential for Azure, and that is using a service principal. So I'm able to authenticate using an Azure AD token. This is how simple it is. Then in the kernel, I add both a text completion service endpoint and a chat completion. I'm not going to use the chat one, but I thought I'd add it just to show. So I've added the text completion service. I've got a config, which is the deployment name, which that is my Azure AD account. Sorry, that is the model I'm using, which would be text DaVinci 002. And I've got an endpoint defined, which is the URL that I would have seen in Azure, in the Azure OpenAI service in the portal. So that is that URL that my service is exposed on. Once I've configured the kernel, I can then just start to define prompts that achieve tasks. Now I can do a lot more. I just simply don't have the time, but I'm happy to run through this perhaps in a future session. So what we have is here we have a prompt that extracts data, movie data as JSON from a movie review. The movie is not included in here. It is just the instruction or the prompt itself. The context, however, as I mentioned, is provided here, down here. So once I create the prompt, I then use the kernel create semantic function. So I'm now creating a semantic function. It is by default going to be backed by my model, but I could have chosen a different technology or model if I wanted to, but I've just used that initial model. So I'm passing in my prompt, and then what I'm doing is I'm using this semantic function I have created, and I am passing the invoke async, calling the invoke async method with my movie, with 3 movie reviews. So as you can see, I would be basically creating this extract movie data once and running it 3 times. If I look at the result, I've run this previously just to save a bit of time, but here is the movie review, and as you can see, it is actually in the movie, in the text, I have not mentioned the name of the movie. I did mention that it was Sharknado, but incidentally, I got AI to actually generate the movie review. So the Sharknado 2, it's picked that up. The next movie was Platoon. It's done a great job here. Thought the performance of everyone was good. And then finally, I have used, I can't remember, I think it was Gone with the Wind or Sound of Music, apparently. And it thinks everyone did a good job there. Now, notice the format of the JSON was different, and that is actually because in my prompt, I didn't specify how the actors should be, whether it should use a dictionary or whether it should use an array of dictionaries. So next, I have done another example here. This is an example of prompt chaining, a very simple chain. I'm going to translate and summarize some data. Well, actually, I'm going to summarize some data and then translate it. So I've created a summarize prompt, which asks me a TLDR, which is obviously too long, didn't read, but I could have said, please summarize this. And I have also said, please translate this into math, interestingly enough. So I've now got the laws of thermodynamics. Again, I've created two semantic functions, a translator and a summarizer. And then I've chained them. So what I've done is I've used the kernel run async, passed my input text, and I've used a chain of prompts. So the input of one prompt is going to go into the output of the next prompt. So that's where we start to see the power of these models. So this is going to translate and then summarize that. If we jump across to my output, back down here. This is what it has come up with. So this is the result. This is a summarization and conversion to mathematical formula or representation of this information. Super cool. I've never seen anything like it. Finally, the third one, we have an example here. This is another extractor and translator, but this is extracting information from financial points as a bullet-pointed list from a financial summary, and then we are passing this through and asking it to translate into Te Reo Māori. And this is our financial report, and it's quite a complex, long report. I'm not going to go show it in all its glory. Again, we're using the run async, kernel run async. We're, of course, creating our semantic function, and then we're passing through that pipeline. And this is the result. Now, I'm honest, I'm going to hand on heart, I don't speak today. I wish I did. But I understand these models do a fairly good job. GPT-4, I understand, does a much better job. I'm using GPT 3.5. DaVinci 003 here, which is not bad, but not as good as GPT-4. So we'd expect even better result here. So as you can see, or you may not, this is the bullet points we've asked it to understand. So it has actually extracted meaning from this, translated it, and given me the result back. And I've asked it, you may have noticed, I was very careful to ensure translate the text and retain the formatting. Because typically what it will do is, if you have a bulleted list, it will extract the text and then translate it into a blob of text, which isn't necessarily what you want. You want it to retain that bullet points. So that is semantic kernel. It does so much more. It does so much more. I would highly recommend jumping in and having a look. I've got a link at the end, certainly around planners and other techniques. But we're nearly there, folks. So thank you for sticking with us for this. Now I've just used the wrong one. There we go. So this is probably the question I get asked the most. I want generative AI to reason or access my data, reason over or access my data. This is what we call ChatGPT for the enterprise. I have an environment with a bunch of private data to my environment. Maybe it's a bunch of PDFs stored in a storage account somewhere. It could be a SQL database. It could be Cosmos DB. It could be a SharePoint. It could be any number of different or combination of different technologies. How do we do that? Especially when these models clearly have no understanding or view on our data. This is where we need to create an orchestrator or an app server. This is a service that sits in front of where our users are going to interact with. Now, these could be internal users, these could be other applications, or they could be external users. We are going to build an index over our data. Now, typically we'd use cognitive search here, but we could use other technologies. That index is going to be that data, or our representation of our data, chunked up with metadata attached to it. So we might have converted a bunch of PDFs into text, chunked it up, which means break it up into pieces of data, smaller chunks of data, and then built an index that we can search. We can either keyword search or use embeddings to search. Now, that is definitely a topic for another day, where embeddings allows us to use a vector similarity search to provide a much better semantic search over that content. Again, it requires its own topic. We would have our orchestrator. Whenever someone or an application asked a question of our data, the orchestrator would take that request. It would extract keywords or special components of that. It would then query the index, get the results back, or the most relevant results from the index and the content, combine that into a prompt, add the user's question or the application's question or ask of the data, and then pass that prompt over to Azure OpenAI using the REST APIs or an SDK or whatever. The result would then come back and be passed back to the user or application. And that might be interactive or non-interactive. But that is essentially how it works. Now, I've got a quick demo of that because I'm sure many of you want to see this in action. So this is an application you can deploy yourself. It actually spins up in Azure. It'll deploy all the resources you need, including Azure Cognitive Search for the index. indexed a huge number of PDFs. Those PDFs are broken down, converted to text, and stored in cognitive search. And when I ask this service a question, it is going to search the cognitive search index for relevant information, assemble into a prompt, and then give me a result. So I might say, now I've got two sources of data. I've got the health plan for my employees or the people at my organization, and I've also got the HR documents, the role guides, and other things for the employees, for the organization. So I can say, am I covered for dental care, dental extractions? Now, what it's going to do is it's going to the index, bringing back the relevant information on dental extractions from the index, passing that through to as part of a prompt over to ChatGPT, sorry, OpenAI, Azure OpenAI Service, and giving me a result saying it does cover this information, extractions, fillings, root, and here's the relevant document. So this is very similar to how Bing AI does it, if you as you saw the demo before. And we can actually go and have a look at what the thought process was. And this is an example of the prompt. I was asking that question. The prompt that actually was generated was, here is the system. As we mentioned, we have this concept of a system message. This defines on what I can do with this. It is given this is an example of a one-shot example. It is actually, this is not the question I asked, but this is the question that an example question, and the result I want that the model wants is going to respond with, which includes the sources and also includes the answer in this format, which links to the PDFs. And this is how we've told the model to respond to us, and that's how we're able to add the citations. So here is my actual question here. Now I could add on to that. What about anesthesia? So I've added additional information to this question. And as you can see, this is the model is giving me a well reasoned answer to my questions, two questions. We could do this as a chat. I've got an example of that over here as chat, where I've asked, am I covered for dental extractions? Yes, here's the reference. And even if it requires anesthesia. Now, this is an example of the chat interface at play, because importantly, the chat APIs, they have no memory. It's every request is a new request. The model does not know anything about previous requests. So you have to ensure that when you are having a chat, you are actually passing the previous questions. So here's the first question, and here's the response from the model, and here's my second question. So that is really important. It's not obvious these models don't have memory, because that does seem like they do, but you're responsible for implementing that memory. And that's interesting. That goes back to things like semantic kernel, which can help you implement that memory structure and function. Right, so we're really nearly at the end. I really appreciate everyone sticking around for so long. I know we're a little bit over time. How do I decide when I should use Azure OpenAI Service? So Azure OpenAI Service, it is extremely powerful, but there are often other services in Azure which might be more suitable for certain scenarios. For example, the translation service. But this is a good questionnaire, or a good set of questions to ask yourself when you're just deciding, should I use the service or should I use one of the other higher level services or other foundational services. So I need a general purpose model that can handle multiple tasks. It's a good reason for using the Azure OpenAI Service or the generative AI LLMs. I need to generate high quality content while preserving data privacy and security. So that is a good reason to use Azure OpenAI specifically. I need rapid prototyping and quick time to market. So as you can see with the Playground, it's really easy to just prototype something, get everything working. You don't actually need your developers or engineers to do a lot of the prototyping. You can get a SME to prototype some of it, and then you hand it over to developers to do the wiring up and adding of additional grounding information and so on. You need to use a model with little or no training. Ideally, you don't want to have to fine-tune the models. You can, but you want to avoid it if possible. And these models don't typically need fine-tuning. And really, you want to explore any of the types of use cases you've seen. There are so many more. Every day, I come in and I hear about more use cases. Literally, just before this session, I was talking to one of my colleagues, and he was talking about the amazing use cases they just built today, and it's every day it's new use case. So, highly recommend going and having a look, trying this stuff out, seeing what you can do, because you'll be completely amazed with what these tools are actually able to enable. So with that, we're pretty much at the end. There are 3 things I want you to take away or have a look at if you get your time. There is a learning pathway that will take you through developing with Azure OpenAI. I'll cover some of the stuff I've talked about today, dive into a lot of areas in depth, and it's a good place to start. If you do need access to this service, this is how you get access. You go to that form and you fill it in. As I said, it is a limited access service, so go and have a look at the limited access documentation to see if you are currently eligible. Many of you will be. Everyone else will be at some point in the future. Just be aware there is that responsible AI gating to make sure that it's being used in the most responsible way we can enable. And then finally, check out Semantic Kernel on the paved path. It is early version on that, but it is moving extremely quickly. So with that, I am going to open up to Q&A. So how do I train the model on specific type of code generation? Example, generating specific tags for HTML forms, contains structure for jQuery controls. So this, you would obviously be using the Codex models, probably the DaVinci model. You aren't typically going to need to train, but what you would be trying to do is using those one-shot and few-shot techniques. So you would be going, now I'm going to jump straight back in here. You would be typically using Code DaVinci. You would be providing that question, an example HTML, and then you would be providing answer examples. That is how you're going to do it. And you might say, look, I need it to output this particular tag or in this way. So you're going to give it those examples, and then obviously you would have your request to generate HTML that does such and such. So that is how you would do that. Now, these models, you can't really retrain them. You can tune them, but you can't add new code. So you can't add new examples. You can't take a big corpus of your own jQuery, JavaScript, and HTML, and then say, right, I want you to make it look like this. You would need to provide this as much context and information in the prompt as you can. That's the key to this. So is there any waiting for instructions provided by you or the end user? What's the behavior if the end user says to ignore the prior instruction? That's a very, very good question. So the system prompt is designed to have the most waiting, but as we've seen, users have found ways to basically say, pretend you're such and such. Now, what we've typically found is you really want your orchestrator to potentially filter out some of these behaviors. There is no perfect solution to this. The model system message is the best way to do that. But we are seeing people be very ingenious, and you've seen some interesting scenarios. So I don't think there's a magic way. I think system message being very, very clear. Incidentally, there is a concept called recency bias, which means that the instructions further down are found to be more important than or more relevant than the earlier instructions. So that can influence this. It's just something to be aware of. And if you can, provide some filters over top, your own filters over the top of this. When will Azure OpenAI Azure OpenAI be available for all subscription types? So I'm not 100% sure. I know what this. I'm just going to take a guess. Available to everyone, because it is available for it is available for all subscription types, but you do have to be a corporate or organizational customer of Microsoft at the moment with an account team assigned to you. When you go and request access to that through the Azure OpenAI through the form, you'll be asked for a Microsoft contact. If you can put that in, that should be the account team person that you've got at Microsoft. I don't have a timeline when it's going to be open. The gates are going to be open for everyone. I'm hoping not too soon, but I honestly can't give you a timeline on that. We're just hoping as soon as possible. Any other questions in there, Michael? Amazing. Thank you. I really great. I'd love to come back and do more stuff with prompt engineering, but we'll see how that goes.
Thank you, DSR. We've probably reached time. There's some more questions coming in, but I'm sure that people can hit you up on Twitter or LinkedIn. I've put your Twitter handle into the chat, and you can find Daniel on Twitter as well. I've also posted the survey details, and I would appreciate people doing that if they get the chance. And the event code I will put into the chat also. But without any more questions for us tonight, I want to thank everyone again for joining us. It's been an amazing presentation. DSR is such a great presenter and such a great asset to Microsoft. We will get him back on to do a follow-up. So share some more insight as to what you want to hear from him, and we can get that lined up in the future. But with that, I will close the session out and wish everyone a great day, great evening, and I will talk to you all soon. Thank you, everyone.
Thank you, everyone. Thanks, Michael. Have a great night. Cheers, everyone.